surface describe for a given frequency omega the direction of k when you are given a propagation direction, S, then you solve the so-called Fresnel's equation of wave normals. You solve this equation, then you get two possible refractive indices. This means that for a given propagation direction, there are two different refractive indices corresponding to this propagation direction. Then you use this these two refractive indices. You can calculate these two wave vectors. So for a given frequency omega, if you plot all possible k vectors, the collection of k vectors form a double shell structure. This surface is called normal surface. Once you know the refractive index, you can find the corresponding electric field, magnetic field, B field, and E field. Okay? So you can use this corresponding fields to find two things. First thing is about how the phase propagate. The phase propagation is described by the k vector. The other thing that we can find is the so-called pointing vector. Pointing vector is formed by this cross product. When you substitute E1 and H1, you find the pointing vector corresponding to the mode 1. And you use the E2 and H2 to find the pointing vector corresponding to the mode 2. Pointing vector describe the propagation of energy. Okay? So for a beam of light propagating inside anisotropic medium, usually phase propagate along this direction and the pointing vector propagating along a different direction. Okay? So usually K and S are along different directions. Okay? But for some very special situation, for example, when the E or H pointing along the so-called principal axis, then you will find that for those special situations, S is parallel to K. Only for those special situations, S is parallel to K. Okay? But in general, S and K are propagating along different directions. If you use the normal surface equation for a given propagation direction, you are solving for refracting this and find K1, K2, and then you can get this H1, H2. However, there is another way we can find the eigenmodes without relying on the K vector. This alternative method is called, in this alternative method, we derive another kind of surface called index ellipsoid. 这叫折射率椭球啊，折射率椭球。折射率椭球跟这边的 normal surface 有一个主要的差别，是这个 normal surface 通常是双层的啊，是一个所谓double shell structure。但是折射率椭球呢，它是单层的，它就只是一层，它就只是一层的椭球啊，而且它是一个可以叫出名字的椭球。那这边的这个 surface 呢，它的名称呢，其实就叫 normal surface， 但是你没有办法说它是椭球还是球还是什么，一般来说它都不是，都不是那但是呢，在这个跟坐标平面的交叉线上，它会得到一个圆跟一个椭。So normal surface is in general double shell structure, and this double shell structure you cannot identify this double shell structure as ellipsoid or sphere, something like that. It is a more complicated surface, but the intersection of the normal surface with the three coordinate planes always give us one circle and one ellipse. Okay. But now we can use another way to find the eigenpolarization of the mode. The method is called, this new surface is called index ellipsoid. Normal surface describes the collection of K points, but index ellipsoid describes the D vector itself. Let me show you how to derive the so-called index ellipsoid. 现在来看看这个所谓的折射率椭球是怎么得到的。We know that the normal surface is in fact equivalent to this equation. We derive the so-called normal surface equation from this equation. Okay. This equation can be obtained by using the third Maxwell equation and the fourth Maxwell equation. This equation is the so-called Faraday's induction law, and this is the so-called Ampere's law, modified Ampere's law, without current density. Then we substitute this ansatz for plane wave. We substitute this ansatz describing plane EM wave into these two equations. Then, as I have told you that plane wave like this, then del can be replaced by minus ik, and time derivative can be replaced by I omega. So this equation can be rewritten as minus ik cross E equal to minus I omega times mu h. Okay, because now B is equal to mu h. B is the magnetic induction and h is the magnetic field. So both sides has the factor minus I, so this equation can be written as K cross E equal to omega times mu h. Now this equation has the same form as the previous one, but has the different sign. So we get K cross h equal to minus omega epsilon E. Here D is epsilon times E. Remember, now the epsilon is a tensor. Which means that you can describe epsilon as a matrix, 3 by 3 matrix. And we use the principal axis system. So the epsilon matrix now is of the diagonal form. Okay? So from this equation, when you do the cross product K with K cross E and K with omega mu h, since K cross h is minus omega epsilon dot E, so you get this equation. Okay. So as I have already shown to you that this equation can be described by something like this. Ex, Ey, Ez equal to 0. Here, this matrix has a little bit complicated form. Okay. And if this matrix has inverse, then we will conclude that E must be equal to 0 because we can find the inverse of this matrix to get 0 E vector. However, we want to consider the mode located inside this medium, which cannot be zero field. Okay. So how can we obtain this equation but without asking E to be 0? Okay. The only possibility is that M has no inverse. So mathematically, if M has no inverse, then this implies that determinant M is equal to 0. And this condition gives us so-called normal surface. Okay? Now we try another way to use the same equation. But now we change our field variable from E to T. So if we change our field variable from E to T, the same equation can give us so-called index result. D is epsilon times E, displacement field. So if we want to know E can be written as epsilon inverse times D. Okay? So now I multiply epsilon 0 to this equation. I multiply epsilon 0, the permittivity of vacuum, to this equation. Then I get K cross this one. Epsilon 0, epsilon inverse times D plus omega squared mu epsilon 0 times D. Now you see that here we have a new matrix for new tensor. We denote this as eta. Well, now we define this so-called impermeability tensor. Eta. Impermeability tensor is the name of this eta. Okay. Eta is defined as epsilon 0 times the inverse of epsilon. So we can write the equation as K cross eta D plus, since we encounter the non-magnetic material, mu can be approximated by the mu 0, the permeability in the vacuum. Okay, and we know that epsilon 0 times mu 0 is equal to 1 over c squared. C is the speed of light in vacuum. So this is equal to omega over c squared times d. So now we have an equation describing the relation between D and K. And we know that the wave vector K is related to the propagation direction S by this relation. Here N is the refractive index. So we can substitute this form of K into this equation to get N squared omega over C squared S cross eta D plus omega over C squared D equal to 0. Then we divide the whole equation by N squared omega over C squared and find S cross eta D plus 1 over N squared D equal to 0. Now we see the details of this equation. to vector analysis, A cross B cross C. For three vectors, if we consider this kind of cross product and the cross product twice, the result is equal to A dot C times B minus A dot B times C. Now this eta D is just this C vector, and A and B are both equal to this S vector. And notice that the S vector is unit vector, so S dot S is equal to 1. Okay? So that equation now becomes S dot eta D times S minus S dot S eta D plus 1 over n squared D equal to 0. Okay, we can rewrite this as eta D minus S dot eta D times S equal to 1 over n squared D. What does this equation describe? To understand the physical meaning of this equation, notice that according to Maxwell equations, the first Maxwell equation, divergence D equal to 0 if we have no charge density. Okay. And the divergence D equal to 0, which is equal to mu divergence H. We use the same answers, the plane wave answers. We substitute this form into these two divergence equations. We find that K dot D is equal to 0 and K dot B is also 0. As I have already mentioned that once we have this K vector, we have this D vector, this H vector, both of which is perpendicular to this K vector. And in general, the E vector is in the dk plane. Okay. So since K is proportional, is along the direction of S, this means that S is perpendicular to D. S is perpendicular to D. So this means that suppose we choose a coordinate system whose new z-axis is along the S direction. Then in this new coordinate system, the D vector will have only the X component and Y component without the third component. Okay, so this means that we can choose a new coordinate system. Suppose I call it S prime. This name is not the usually used frame. I just call it S frame temporarily. 好，就是暂时这样叫它。那这时候呢 ，when we write all components of this equation in this chosen coordinate frame, then suppose we use eta matrix eta 1 1, eta 1 2, eta 1 3, eta 2 1, eta 2 2, eta 2 3, eta 3 1, eta 3 2, eta 3 3. We use this matrix to represent the eta tensor in this coordinate system. Then this equation tells us that you see, originally we have the eta matrix. The eta matrix has 9 components. But since here we have this term, and as I mentioned that in this coordinate system, the S vector is in the third component. Okay. We choose a coordinate system so that the S vector is along the third component, the third axis. Then in this S frame, this S coordinate system, this equation tells us that this result. And you see that now these two components of eta matrix are useless because they multiply 0 to get 0. So the useful part of this eta matrix are in fact only this 2 by 2 matrix. And we denote this 2 by 2 matrix by eta t. Eta t is defined as eta 1 1, eta 1 2, eta 2 1, and eta 2 2. So in this S frame, the eta tensor, the useful eta tensor, has only the 4 components. And since eta matrix is the inverse of epsilon matrix times the constant, and the epsilon matrix is Hermitian. So eta is also Hermitian. Hermitian matrix. Hermitian real matrix is just a symmetric real matrix. Then this kind of matrix has the very nice property that their eigenvectors are orthogonal and their eigenvalues are real. Okay, 就是这个所谓的 Hermitian 矩阵，它有个特色，就是它的 eigenvector 都是正交的，而它的 eigenvalue 都是都是实数。那这时候你看这个东西就很有趣，就是说。假设我现在把这个直接叫做 D 了，因为它 D3是不存在的，那这个就被写成这样的。So now this equation can be rewritten as eta t b equal to 1 over n squared times d. So you see that now 1 over n squared is the eigenvalue of this eta t matrix. Okay? And since eta t matrix is Hermitian, we know this 1 over n squared factor. This quantity is real, not complex. Okay? 所以这个 n 是什么 ？n 就是我们要解的那个 n， 就是我们要解的那个 n。我们前面是用normal surface 去解除 n， 现在我们可以用这个东西来解除。Originally we use so-called normal surface to obtain the n. Now we can use this equation to find n. Now n play the role of eigenvalues of this eta t. 所以你可以用这个方式去解出这个 n 出来，解出 n 出来。那现在如果我要画一个图来看这个 n 的形式的话，现在我要把这个方程式呢，再画一个样子你比较容易去理解怎么从图形上看出这个 eigenvalue 出来So now we can describe这边其实还没有真正推出所谓的 index unisolid 但是我现在要开始推这个所谓的 index unisolid 它实际上是个什么东西？是这样子So now we consider the so-called index unisolid. How we start? We know that the EM energy we consider the energy density of the EM wave. We now consider only the electric field part. We denote the electric field energy density, which is equal to 1/2 E double D. 1/2 E double D. And now we use D as our dynamical variable. So this can be written as EX times DX as EY times DY plus BC times BC. And since now we use the principal axis system, the epsilon is diagonal form. So this can be written as dx squared over epsilon x, because dx is dx over epsilon x plus dy squared over epsilon y plus dc squared over epsilon c. This is because now E is this one. Okay? So,这个我先留着。 When I multiply 2 epsilon 0 to this equation, I get 2 epsilon 0 times UE is equal to 3x squared over nx squared plus by squared over ny squared plus bz squared over nz squared. This is because we have already learned that epsilon x is equal to, we know that we have 3 reference refracting indices. They are defined as epsilon x over epsilon 0. Epsilon y squared is epsilon y over epsilon 0. And epsilon z squared is equal to epsilon z over epsilon 0. Okay? So we have this equation. But you see that for band wave, the UE is a constant. 那就算不是 constant， 其实也没有关系啊，就是你的 d 的方向是固定的啊。那所以这时候我们可以做一件事情是这样，你把它除过来啊，然后你定义一个新的东西是这样啊。You can define the ratio between d and the square root of 2 epsilon 0 UE. Define this as R. R means x, y, z. Notice that now this R is not the position vector. It is just the ratio between the d vector and the square root of the constant times energy density. Okay? If we use this definition, then we can rewrite this equation as this form. Okay? So now we have an equation of this form. This equation describes an ellipsoid. The 3 principal axes are nx, ny, and nz. Okay. This equation describes the d vector. Okay. Normalize the d vector. Normalize the d vector. And so if we change our coordinate system from the principal axis system to the S-frame system, then this can be rewritten as d times eta times d equal to 1。这边是equal to 1。这边应该是变成这样。因为我们刚才这边看到这个事情啊，这边其实是伊塔 t 了啊，就是说这什么意思呢？就是说我在 principal axis 里面我去写 index ellipsoid，它会长这样。那我如果跑到刚刚所说的那个 S 坐标系啊，就是 k vector 朝着 S 朝着一个方向，然后我的新的 x 轴跟新的 y 轴是垂直于那个 s 方向的时候，我到那个新的坐标系统去写的时候呢，我们刚刚不是推出一个这样的式子来，好，那现在我们如果把 d vector， 我们刚刚把那个 d vector 呢乘上去的时候，会得到一个什么？会得到一个这样的式子，这样的式子，好，这样的式子。那这样的式子告诉你什么意思啊？这样的式子究竟告诉你什么意思？那这边我们看到的是说 eigenvalue 是 1 over n square， 伊塔 t 的 eigenvalue 是 1 over n square。好，那我们现在还可以用另外一种意思来看，好，什么样的意思呢？就是说，现在左右去内积这个 d， 啊，内积这个 d 的话，好，你看看会得到一个什么东西？这边出现的是左边是长这样的，右边是 d square over n square。可是 d square over n square 究竟是什么？好，我们来看一下。So now we discuss what is d square over n square. We know that we have k cross e equal to omega mu h, okay? And k cross h equal to minus omega d. Okay. So d is minus k over omega cross h. Okay. And this is k over omega cross h can be obtained from this k over omega mu cross h cross e， 其实就跟刚刚那个式子是一样的，啊，跟刚刚那个式子是一样的。那现在这个东西究竟要告诉我们什么？ So d is minus k cross e over omega square mu, and this is k dot e times k minus k square times e over omega squared mu. Okay? So if we now calculate if now I calculate d dot d, which is equal to d squared, and the first d I just write in d, and the second d I use this equation. And now this is equal to, since k is perpendicular to d, so d dot k is equal to 0. Then now 2 minus sign gives us positive sign, k squared and e dot d over omega squared mu. Okay? So if I multiply it by epsilon 0, and remember that omega squared mu epsilon 0 is equal to omega squared over c squared. And the k squared is equal to n squared omega squared over c squared. So this means that the d squared is equal to n squared times epsilon 0 e over d. Okay? But we already know this part is 2ue. So this is equal to 2 n squared times 2 epsilon UE. Okay? So this equation tells us d squared is n squared times 2 epsilon 0 UE. So this gives us 2 epsilon UE. Okay? So this means that we can divide the whole equation by 2 epsilon UE and get this. So this is just the same index ellipsoidal equation, but we use a new coordinate system. Okay, we change our coordinate system from the original principal axis system to the new coordinate system. In this new coordinate system, the third axis is the s vector direction. Okay, then we have this equation. So this means that1 over n squared。好，这边我主要要讲的是这样，就是说 ，OK， 我知道了。So in this new coordinate system, you can write the result as something like this: eta 1 1 cos 1 squared plus 2 eta 1 2 cos 1 cos 2 plus eta 2 2 cos 2 squared equal to 1。OK， 就是你的这个 r vector， 就是这 x y z 现在转换到新的坐标。好，那新的坐标呢，把它叫做 cos 1 cos 2。现在没有 z 了，啊，现在没有 z 了，因为呢，你在新的坐标之下没有 z 分量。好 ，so when we change our coordinate system from the standard principal axis system to the s prime, the cos 3 becomes 0, and the cos 1, cos 2 plays the role of x and y. Okay, and in general, this diagonal form nx squared, ny squared, nz squared is replaced by this eta t matrix component. Okay. Now, if we rotate our coordinate system further with respect to the s-axis, then we can diagonalize this expression. This becomes cos 1 prime squared over n1 squared plus cos 2 prime squared over n2 squared equal to 1. Okay, this form can be changed into this form by rotation with respect to the s-axis. So you know that now when we rotate our coordinate axis to the first d vector eigenvector direction, we get the length equal to n1. And if we rotate our coordinate system axis so that if cos 1 prime equal to 0, we get cos 2 prime absolute value equal to n2. So the magnitude of the semi-axis is just equal to the eigenvalue n. So this means that originally we have this index here, so then I consider the propagation direction s, and consider the plane perpendicular to the s vector. This plane intersects with the index here, so the intersection is an ellipse. And the ellipse has one major axis of length n1, and the minor axis have minor axis of length n2。好，所以这样你就可以根据这个半长轴、半短轴去找出你的折射率。好，找出你的折射率。好，我们这边先休息10分钟。好，先下课。